Dear students, in this video we are going to see the algebra of complex numbers, which is a first part of chapter 1 in this course. Now we'll start from the definition of a complex number. A complex number is an expression of the form a plus bi, where a and b are real numbers and I square is equal to -1. The real part of this complex number is a. The imaginary part of this complex number is b. Okay, now you see the note 1. Two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal, which means suppose we have two complex numbers. When we say two complex numbers are equal, suppose the real part of the first complex number is equal to the real part of the second complex number and the imaginary part of the first complex number is equal to the imaginary part of the second complex number, then we can say that two complex numbers are equal. That is given here in note 1. And in note 2, a complex number whose real part is 0 is called a pure imaginary number, is described in note 2. That is, suppose here you see the general form of the complex number is a plus bi. Suppose here this real part is 0, then we can say that this complex number is pure imaginary number. The complex number is pure imaginary number. Now, complex numbers are written in the form a plus bi, as we discussed earlier. Okay. Now here what is a? Actually a and b are any two real numbers, but here when we describe complex numbers we give the specific name for this part. The name of this part is real part, that is a. Name of this part is real part, that is called a. Now here the name of this b is called imaginary part of the complex number. So a plus bi is a complex number. Here a is real part and b is imaginary part. Simply you can remember with I, what is here appearing the real number is called imaginary part. Here without I, here which real number is appearing in the complex number is called real part. Now here we will see how to add two complex numbers. See, when adding complex numbers, add the real parts together and add the imaginary parts together. See here, see this example. Now 3 plus 7i is a first complex number. 8 plus 11i is a second complex number. Here we are going to add these two complex numbers. So how to add? As we discussed here, we have to take the real part of the first complex number. This is real part in the first complex number. This is the real part in the second complex number. So what we have to do, you have to add this real part with the real part of the second complex number, which means 3 plus 8, that is 11. So this is the real part of the final complex number. Similarly, what is the imaginary part of the first complex number? That is 7. Here imaginary part of the second complex number is 11. So you add these two, 11 plus 7, that is 18. So you try 18i. So the sum of these two complex numbers is 11 plus 18i. This is the way how to add the complex numbers. Now here we see how to subtract the complex numbers. When subtracting complex numbers, be sure to distribute the subtraction sign, then add like parts. Now you see this example. You see 5 plus 10i is one complex number. Now we are going to subtract this number from the first one. So 5 plus 10i minus 15 minus 2i. Now here you have to distribute this symbol to the second complex number. Now you distribute here this minus 1 here with 15, that is minus 15, minus 1 with minus 2i, that is plus 2i. So that now after distributing the sign, see you have to add like parts, which means now what is the real part here in the first complex number? 5. What is the real part in the second complex number? That is minus 15. So now 5 and minus 15 you add, so you will get minus 10. Now what is the imaginary part of the first complex number? That is 10. Now imaginary part of the second complex number, that is 2. So that 10 plus here, so 2, 12i. So this is the final answer when you subtract these two complex numbers. Now here we are going to see how to multiply the complex numbers. You see, when multiplying complex numbers, I use the distributive property and simplify. Actually, this is the usual method when we do in real numbers. Same process here we are doing for the complex numbers also. Now you see 3 minus 8i. This is the first complex number. 5 plus 7i. This is the second complex number. So here what we are going to do, use the distributive property, which means now you see here, take the first number, that is the real part of the first complex number. You distribute this 3 with the second complex number. So now you see 3 multiply 5, 15. Now 3 multiply 7i, that is 21i. Okay, which means we distribute 3 to both. Now similarly you do the distribution of minus 8i to these two terms. Now minus 8i multiply with 5, that is minus 40i. Minus 8i multiply 7i. So here minus 8, 7, 56. Here I multiply I squared. Here you have to think here. Minus 56 I squared. Okay. Now what is I squared? You know that when we discussed the definition of the complex number, we have seen I squared is nothing but minus 1. Here to remember, the value of I squared is minus 1. When you complete this entire course, you have to remember I squared value is minus 1. Now, so 15 is the real part. Now here you see minus 56, but I squared is minus 1. So if you put minus 1 here, minus 1 minus, it will become plus 56. So now 15 is a real part here, 56 is the real part. So now you add these two numbers. So the real part is 71. Here minus 19i. So now here minus 19 is the imaginary part. So this is the final answer when you multiply these two complex numbers. So this is the final answer. Actually this is called the a plus bi form. The complex number is written in a plus bi form. Why? Because here this is a, real part of the complex number. Minus 19 is the imaginary part of the complex number. So the final answer is written in the form of a plus bi. Now we will see how to write the complex conjugate. Now what is complex conjugate? You see here, generally we write any complex number as z is equal to a plus bi. This is the notation, z is equal to a plus bi. Okay. How to write the complex conjugate? Complex conjugate is nothing but z bar is equal to a minus bi, which means complex conjugate means you have to change the sign of the imaginary part in the given complex number. Now z is a plus bi. Now the imaginary part is b. Okay, here what is the sign of the imaginary part? That is plus. Now when you write the conjugate, conjugate means put z here bar. Conjugate means write the real part as it is. Now you change the sign of the imaginary part. So now here imaginary part is plus, means plus b, sign is b, sign is plus. So now you change the sign, that is minus bi. So this is the complex conjugate of the given complex number. You see few examples here. Z equal to 3 plus 4i. This is the given complex number Z. So what I write here, Z bar, that is complex conjugate, which means now you see in the real part no change now, but in the imaginary part here plus 4 is the imaginary part. When you write the conjugate, you change the sign of the imaginary part. So here plus 4, so I change here minus 4. So this is the complex conjugate. Similarly, you see here, is it equal to minus 5i plus 7, but I write the conjugate of the z is equal to, see here real part is 7, no change, but the imaginary part is minus 5, so you change here minus into plus. So this is the complex conjugate of the given z. Similarly, you can write here z is this, z bar is nothing but 6. Here 5 by 2 is the imaginary part, so I can write minus 5 by 2 is the imaginary part. So this is the way how to find the complex conjugate. Okay, so now where we are going to use the complex conjugate concept. Now you see we have seen addition, subtraction and multiplication of two complex numbers. Now here we are going to see how to divide the complex numbers. Okay, so how to divide? It is given, multiply the numerator and denominator by the complex conjugate of the complex number in the denominator of the fraction. I will explain through one example. Now you see here 7 plus 2i divided by 3 minus 5i. Now how to divide this complex number 7 plus 2i by 3 minus 5i? Very simple. Now first we have to find the complex conjugate of the denominator value. This value, this is the denominator value. So now 3 minus 5i is the denominator. What is the complex conjugate of 3 minus 5i? That is 3 plus 5i, because here imaginary part is minus 5, you change the sign of the imaginary part, that is plus 5. So this is the complex conjugate. So what we have to do now, 7 plus 2i divided by 3 minus 5i. This is the given question. Now to divide this, what we have to do, you multiply the numerator and denominator by the complex conjugate. You see here, in the numerator what I am multiplying, 3 plus 5i. In the denominator what I am multiplying, 3 plus 5i. So next what I am going to do, multiply 7 plus 2i with this. So now these two you multiply, 7 plus 2i multiply with 3 plus 5i. Okay, right in the numerator. Okay, we know that distribute 7, so 7 3 21, next 7 5i 35i, next plus 2i multiply 3 6i, 2i multiply 5i 10i square. So now similarly you multiply these two terms in the denominator. Now this is nothing but a minus b, a plus b, which means a squared minus b squared. So now or else you can distribute. Here I have distributed. Either you apply the rule or you can distribute. Okay, now what you will get, 21 plus 41i minus 10 divided by 9 plus 25. So here one thing is important, when you get I squared you put minus 1, when you get I squared you put minus 1, so that you can simplify. So final answer is 11 plus 41i by 34. Actually you can write this as 11 by 34 plus 41 by 34 I. Why writing this? This is right, but this is the form of a plus bi. This is a real part 11 by 34. This is imaginary part b, that is 41 by 34. So this is the division. This is the value of the division of 7 plus 2i divided by 3 minus 5i. This is the final answer. Now write in the form of a plus bi. Now you can try how to subtract, to multiply, to divide. You try all these 5 constraints. And you can try these 4 constraints also. How to subtract, how to multiply, how to simplify this, and how to find the value of this. You try.